Hello GATE aspirants, welcome to part 15 of GATE solid state physics series. Question number 16. Crystal structures of two metals A and B are two-dimensional square lattices with same lattice constant A. Electrons in metals behave as free electrons. The Fermi surfaces corresponding to A and B are shown by solid circles in figures. The electron concentration in A and B are Na and Nb, then the value of Nb upon Na is. Now for metal A, value of K is equal to this point, that is pi by A. Similarly for B, it will be radius of this circle. So this part is pi by A and this is pi by A. So we can calculate this. So Kf for B, it will be under root pi by A square plus pi by A square, and that is equal to root 2 into pi by A. Now for 2D square lattice, value of EF is equal to h cut square by twice m into 2 pi n, and this is also equal to h cut square kf square by 2m. That means EF of B upon EF of A, it will be equal to NB upon NA, and that will be equal to KF square of A of B upon KF square of A. So for B it will be root 2 by pi by A the whole square upon pi by A square, and that is equal to 2. So answer will be 2, option B. Next, question number 27. The temperature dependence of the electrical conductivity sigma of three intrinsic semiconductors A, B and C is shown in figure. There is a graph of ln of sigma versus T inverse. Let EA, EB and EC be the band gaps of A, B and C respectively. Which one of the following relations is correct? Now sigma is equal to e raised to minus Eg upon twice kBt for intrinsic semiconductor. That means ln of sigma will be equal to minus of Eg upon 2 kb into 1 by T. So this graph will be a straight line whose slope is equal to minus of Eg upon 2 kb. That means slope is proportional to Eg. So if slope is large, Eg will be large, and slope is largest for A. So EA will be greater than EC will be greater than EB. So option D is correct. Next question. The X-ray diffraction pattern of a monoatomic cubic crystal with rigid spherical atoms of radius 1.56 angstrom shows several Bragg reflections, of which the reflection appear at the lowest 2 theta value is from 111 plane. If the wavelength of X-ray used is 0.78 angstrom, the Bragg's angle corresponding to this reflection and the crystal structure respectively are. Now lowest plane is 111 plane. That means it is an FCC lattice, because condition for FCC lattice is all numbers, all HKL will be either odd or either even, and for simple cubic all planes are possible, and for BCC only those are possible for which S square plus K square plus S square is 1. So this is the case, so this will be FCC, and for FCC A is equal to 2 root 2 into R, and D, interatomic spacing, is equal to A upon under root H square plus K square plus L square. Now here A is equal to 2 root 2 into R, and H, K, L are 111, so this will be under root 3. And we have Bragg's law, 2D sin theta is equal to n lambda, that gives us sin theta is equal to n lambda upon 2D, and that is n lambda by 2, and D is 2 root 2 R root 3. So sin theta is equal to n is 1, lambda is given 0.78 angstrom into root 3 upon 2 into 2 is 4 into root 2 into R is 1.56 angstrom, and this comes out to be, theta comes out to be 8.80 degree. So that means 2 theta is equal to 17.60 degree. So it is FCC, face centered cubic, with 2 theta value equal to 17.6. So option B is correct. Next question. An infinite one-dimensional lattice extends along x-axis. At each lattice site, there exists an ion with spin half. The spin can point either in plus z or minus z direction only. Let Sp, Sf and Sa denote the entropies of paramagnetic, ferromagnetic and antiferromagnetic configurations respectively. Which of the following relation is or are true? Now among para, ferro and antiferro materials, ferro is most ordered. So it will be having lowest entropy. So lowest will be of ferro and highest will be of paramagnetic material. So highest will be of paramagnetic material. That means we can say entropy of paramagnetic material is greater than entropy of ferromagnetic material, and entropy of paramagnetic material is greater than entropy of antiferromagnetic material. So these two options are correct. Now this is comparison between antiferro and ferromagnetic material, which depends on temperature only, and here temperatures are not specified, so we cannot comment on this. So these A and D are always true. So option A and D is correct. Next, question number 50. An extrinsic semiconductor shown in figure carries a current of 2 milliampere along its length parallel to plus x-axis. When the majority charge carrier concentration is 12.5 into 10 raised to 13 per centimeter cube and sample is exposed to a constant magnetic field applied along plus z direction, a Hall voltage of 20 millivolt is measured with the negative polarity at y is equal to 0 plane. Take the electric charge as 1.6 into 10 raised to minus 19 coulomb. The concentration of minority charge carrier is negligible. Which of the following statement is or are true? Now here voltage is measured with respect to y is equal to 0 plane and it is given negative polarity. That means E is in minus y direction. So this will be in minus y direction and magnetic field is in plus z direction. Current is going in x direction. So that means movement of electron will be in minus x direction. So V will be in minus x direction. So electric field corresponding to the Hall voltage is in plus y direction. So this statement is wrong. Now we have to check other options as well. Now we will consider if the majority charge carriers are holes. If this is the case, then force F is equal to, expression for force is this, F is equal to charge Q into V bar cross B bar. So we will use these values here. So we are considering holes. So holes have positive charge. Then velocity is V and B and directions are minus x cap into z cap. So this is the direction. So x cap cross z cap is minus y cap. Minus it will be plus. So EVB into y cap. So holes cannot be the majority charge carriers. Let us check for electrons. F is equal to, now charge on electrons is minus E into VB into minus x cap cross z cap. So this will be minus of EVB y cap. So this is correct. So electrons are the majority charge carriers. So option A is correct. Now Hall voltage is equal to IB upon NET. I is the current, B is magnetic field, N is majority charge concentration, E is charge on electron and T is the thickness and VH is Hall voltage. So from here B is equal to VH into NET upon I. So B is equal to, Hall voltage is given, that is 20 millivolt. So 20 into 10 raised to minus 3. Then N is concentration is 12.5 into 10 raised to 13, but it is in centimeter cube. So into 10 raised to 6 per meter cube. Into E is 1.6 into 10 raised to minus 19. Into T is thickness. Thickness is given 0.5 into 10 raised to minus 2. And this whole thing divided by current, and current is 2 milliampere. So 2 into 10 raised to minus 3. This gives us B is equal to 1 Tesla. So magnitude of applied magnetic field is 1 Tesla. So B, option B is correct. And Last option, magnitude of Hall coefficient is. Now Hall coefficient RH is equal to 1 upon Ne. So this will be 1 upon Ne is 12.5 into 10 raised to 13 16, that is 19, into 1.6 into 10 raised to minus 19, and this is equal to 0.05 meter cube per coulomb. So this is also not correct. So option A and B are correct for this question. Next question. The temperature T dependence of magnetic susceptibility Chi of certain magnetic materials are given below. Which of the following options is or are correct? Now for first diamagnetic material. So for diamagnetic material, susceptibility is negative and constant, and its value is very small. So graph of Chi versus T, it will be horizontal line. Since it is a constant, and that we are getting here. So P is 3. So 3 goes to P. This option is correct. Then for paramagnetic material. So for paramagnetic material, Chi is equal to C by D. That means Chi is inversely proportional to temperature, and it will be a rectangular hyperbola. So for this paramagnetic material, we will get this 4. So paramagnetic material is 4. So Q goes to 4. So this is correct. 4Q is correct. 4Q is correct. Then for ferromagnetic material, Chi is equal to C upon T minus Tc when this temperature is greater than Tc. So that means this one is for ferromagnetic material. And for lastly for antiferromagnetic material, Chi is equal to C by T plus Tc. So this is the formula. So last, this one is antiferromagnetic material. So that means 1 goes to S, 2 goes to R, and 3 goes to P, and 4 goes to Q. That means this option is correct, and also this option is correct. So option C and D are correct. Next, apart from the acoustic modes, 9 optical modes are identified from the measurements of phonon dispersion of a solid with chemical formula A and Bm, where A and B denote the atomic species and N and M are integers. Which of the following combinations of N and M are possible? Now here it is given, number of acoustic modes is equal to 9. No, here optical modes are given. So number of optical modes are 9. Similarly, number of acoustic modes it will be 3, because if it is 3-dimensional, then it will be 3. So that means total number of modes is equal to 12, and that will be equal to 3 into some constant P. So this is 3, and this will be 3 into P minus 1. So that gives us P is equal to 4, and that is also equal to N plus M. So that means N, if N is 2, then M will be 2, and if N is 3, then M will be 1. So these are the possible combinations. So option B and C are correct. Next, a material behaves as superconductor below critical temperature Tc and as a normal conductor above Tc. A magnetic field B bar is equal to Bz cap is applied when temperature is greater than Tc. The material is then cooled below Tc in the presence of B bar. Which of the following figure represent the correct configuration of magnetic field lines? So if temperature is less than Tc, then that means it is superconductor, so it will act as perfect diamagnet. So this option is correct for T less than Tc. And when temperature is greater than Tc, in that case it is not a perfect diamagnet. So option A is correct. So here option A and C are correct. So these are all the questions from GATE 2024 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.